Namaste bachon, hope you're ready for some interesting questions. This time on DeBrooglie wavelength in just 2 minutes. Very important 2 minutes for DeBrooglie wavelength. You know the DeBrooglie equation is lambda, that is h by mv. H is your Planck's constant, mv represents your momentum, so that is basically your mass into the velocity. So you know this basis of the DeBrooglie equation. Let us see this interesting question. This question tells you about the graph between the DeBrooglie wavelength versus the associated momentum. You know that the DeBrooglie wavelength is h by mv. It is inversely related to the momentum. So therefore it has to be neither 2 nor 4. It has to be decreasing. The lambda should decrease with momentum. So the relationship between lambda and p should be either 1 or 3. But you see that the equation is, for you to get a linear equation, you need something as y is equal to minus mx. Here you're not getting an equation as y is equal to minus mx, you're getting y is equal to 1 by x. So therefore it is a rectangular hyperbola, and so that is represented by your equation 1. So the first answer 1 is the right one. The next question is basically talks about a particle which is dropped from a height h. What is the DeBrooglie wavelength for such a particle in function of h? How is it related to h? You know this basic thing that when there is a particle is present at a height h, so it needs to have its mass, it needs to have a velocity. The velocity will be directly dependent on what? If it is at a height h and is dropped down, what do you get the velocity as? Velocity is directly dependent on root 2 gh, right? So the velocity becomes directly related to root 2 gh, and so therefore v is equal to root 2 gh, which means that the DeBrooglie wavelength is nothing but h by mv, where m is the mass, v is equal to root 2 gh. So therefore it is directly related to h to the power minus half. So therefore the DeBrooglie wavelength becomes related to h to the power minus half. Right. We go to the next interesting question. The DeBrooglie wavelength associated with an electron which is moving with a speed 5.4 into 10 to the power 6. So this is just basically a direct substitution wherein you need to use the electron mass. Remember, mass of an electron 9 into 10 to the power minus 31. So put that and you get h. Substitute the value of h by mv. You will get your answer as 0.135 nanometer. Good. We'll do this next question in the next shot. Remain logged in.